Hello everyone and welcome to today's webinar, Best Practices for Security Compliance on AWS. My name is Jarret. I'm a Solutions Architect with Amazon Web Services. We also have Brad Schulteis, Senior AWS and Security Architect from Rackspace, and Jarret Raim, Director of Managed Security at Rackspace, speaking with us today. If you have any questions during the webinar, please enter them at the Q&A window. We'll collect those questions and answer them either during the webinar or during the Q&A session at the end. With that said, let's get started. This is a high-level agenda of today's webinar. I'll do a quick overview of AWS security, and then I'll hand over to Brad and Jarret to talk about security by design and how Rackspace can help customers in this area. In this 21st century of digital economy, data and intellectual property are one of the most valuable assets of any company. Security has become a major concern for companies hosting their applications on-prem and for companies trying to adapt cloud. IDC released a report last year and found out that customers can be more secure on AWS than their on-premises environment. AWS provides an extensive set of security enablers and capabilities to help customers keep their environments more secure on AWS. Some of the security enablers we provide are extensive monitoring and logging through our CloudWatch and CloudTrail services, identity and access management through our IAM service, encryption through our key management service. For example, Amazon CloudWatch is a monitoring service for AWS cloud resources and applications you run on AWS. You can use Amazon CloudWatch to gain system-wide visibility into resource utilization, application performance, and operational health. CloudTrail provides visibility into user activity by recording API calls made on your account. CloudTrail makes it easier to ensure compliance with internal policies and regulatory standards. AWS IAM enables you to securely control access to AWS services and resources. Using IAM, you can create and manage AWS users and groups and use permissions to allow and deny their access to AWS resources in a very granular level with full control and visibility. IAM also enforces strong authentications using password policies and enforcing multi-factor authentication. Encryption is very key, both on-prem and on the cloud. But many enterprises have a difficult time deploying encryption for data at rest on their on-premises environment. AWS makes tools readily available for encryption with services such as our key management service and an optional cloud hardware security module. With these enablers, it's so easy to encrypt data at rest as well as in motion. So what basically IDC stated was that to create a similar environment inside the enterprise that could match the security capabilities that we provide, an enterprise would need to develop a very robust security program that would require extensive resources. While it may be possible for an organization to build such a program, most organizations will find it beyond their financial means. AWS environments are constantly monitored 24/7 by our security team. Another security enabler is CloudTrail. As I mentioned in the previous slide, our CloudTrail service lets you record, monitor API calls on your account. The logs produced by CloudTrail enable security analysis, resource change tracking, and compliance auditing. Another important security enabler that we provide to our customers is Amazon Inspector. Amazon Inspector helps you to identify security vulnerabilities as well as deviations from security best practices in applications both before they are deployed and while they are running in a production environment. This helps improve the overall security posture of your applications deployed on AWS. Amazon Inspector allows you to define standards and best practices for your applications and validates adherence to the standards. This simplifies enforcement of your organization's security standards and best practices and helps to proactively manage security issues before they impact your organization. AWS is a global infrastructure. Our global infrastructure is built around regions and availability zones. A region is a physical location in the world where we have multiple availability zones. Availability zones consist of one or more discrete data centers, each with redundant power, networking, and connectivity. housed in separate facilities. These availability zones offer you the ability to operate production applications and databases which are more highly available, fault-tolerant, and scalable than would be possible from a single data center. The AWS Cloud operates 35 availability zones within 13 geographical regions around the world. Our customers have full control on where their data resides, and they can choose a region that meets their compliance requirements. We also provide a number of security enabling services such as Elastic Load Balancer, auto-scaling, and Route 53 to help customers mitigate DDoS attacks. For example, in the case of web applications, you can use our Elastic Load Balancer to distribute traffic to many Amazon EC2 instances that are configured to auto-scale for the purpose of serving surges of traffic, whether it's a result of a flash crowd or an application layer DDoS attack. Amazon CloudWatch alarms are used to initiate auto-scaling, which automatically scales the size of your Amazon EC2 fleet in response to events that you define. This protects your application's availability even when dealing with an unexpected volume of requests. Amazon Route 53 is another security enabler. Amazon Route 53 is a highly available and scalable domain name system service that can be used to direct traffic to your web application. Amazon Route 53 uses sharding and striping, so end users can access your application even if the DNS service is targeted by a DDoS attack. AWS also enables your customers to use their existing tools to manage and control the resources in AWS. One of such enablers is Identity Federation. With Identity Federation, external identities such as federated users are granted secure access to resources in your AWS account without having to create IAM users. These external identities can come from your corporate identity provider such as Microsoft Active Directory or from the AWS Directory Service. Customers can also use dedicated private connections using Direct Connect to connect their on-prem environment to AWS. Customers can also have the choice to generate an encryption key using their existing key management infrastructure and import that key to AWS KMS for greater control over the creation, lifecycle management, and durability of your key in KMS. Imported keys are designed to help you meet your compliance requirements. Apart from all the security enablers I discussed, such as CloudWatch, CloudTrail, key management service, we are also certified and accredited by a wide range of regulators and industry bodies. Here is a list of key bodies that have either certified us or we have a workbook of guidance showing you how to validate an AWS environment against these standards. If you look at the slide, you're looking at ISO standards, PCI, FedRAMP, pretty much all the major standards that are available in the market right now. So due to our breadth and depth of our services and the security enablers that we provide, you can host any type of workload on AWS with security and can meet your requirements. At AWS, we have a shared security model where we are responsible for some aspects of security, whereas you get to choose other security measures you put in place. As AWS, we are responsible for security of the underlying infrastructure. That, of course, includes physical security across our regions, our data centers, our availability zones, our edge locations. We are also responsible for the security of the foundation services that underpin the AWS environment. This includes the infrastructure that supports our compute, storage, database, and networking services. As a customer, then you have the choice of what security controls you choose to deploy by using some of our security enablers to protect your virtual networks, your servers, your data, and access control policies you use to put in place. With that said, I now hand over to Brad to discuss more on the shared responsibility model and the security by design concept.
Thank you, Sai. Again, my name is Brad Schulteis. I'm a senior AWS and security architect here at Rackspace. I previously worked at AWS as well as for the U.S. federal government. Today I'm going to be talking about how we at Rackspace take on a lot of those responsibilities for our customers when we help them build secure environments in AWS from the ground up, as well as layer on additional active security services. All right, so let's make sure we're all on the same page here when we're talking about security. Unfortunately, security in a lot of organizations is somewhat of an inside joke. That's because in reality, it's almost impossible to apply security measures to an IT system after the fact, which is what we tend to do almost every single time. So it plays out like this. Okay, the application's deployed. Now let's secure it. And then we can check that box. So we're more often concerned with the appearance of security than we are with actually creating a secure environment in the first place. So let's practice security in a better way. Rather than attempting to bolt on security retroactively, security by design automates and enforces security best practices throughout the AWS lifecycle. So by completely automating all aspects of our AWS deployment and by leveraging services like CloudFormation, CodeDeploy, and AWS Config, security and compliance in AWS can be made more efficient and ubiquitous. So this is essentially security by design. Why is this important? Well, as I talked about earlier, we're living in a world where our data is paramount, and protecting that data can mean the difference between life and death for your organization. More and more organizations are moving into the cloud and into AWS, and securing these environments is now a top priority for most organizations. But this presents a lot of challenges you must overcome, particularly when you're protecting your sensitive data. AWS provides a lot of tools, as we've seen previously, a lot of services to enable you to operate securely in AWS, but making effective use of these technologies requires a calculated and formalized approach. We need to incorporate secure design practices in every component of our AWS environment. So that's exactly what we accomplished through the 4 phases of security by design. Phase 1 is understanding your requirements. And some of you are probably thinking, well, duh, that's the first step to every large system integration or development effort. We do requirements analysis. Well, at an academic level, you're right, but I've been in this industry long enough to see over and over that requirements analysis is rarely done completely or effectively. More often than not, we start projects with a solution, a component, or a product already in mind. We need to take a step back, review our policies, document the security controls we need to operate, and apply those in AWS to operate securely. And the reason solid requirements analysis is so important is because in phase 2, we start building a secure environment that fits these requirements. So that is key to understanding this. Within AWS, we have a lot of flexibility here. We need that good understanding of our requirements to prevent us from becoming quickly disoriented by all of the options in AWS. Based on these requirements, we can pick a subset of options from within the AWS ecosystem. We can begin to standardize and create templates for deployment within the confines of our organizational requirements. One of the greatest things about AWS is that the majority of our configuration can be turned into executable code, automation sequences, and templates. So as we move from phase 2 into phase 3, we will begin enforcing the use of these templates. So in this step, we are securing our environment through the use of templates that are automatically and systematically applied to all new environments that are being created. This prevents anyone in our organization from creating an environment that doesn't adhere to our secure environment standards. This operationalizes and automates a large portion of our responsibilities in the shared responsibility model. It also prepares us for the final phase where we validate our security posture in AWS. And that brings us to phase 4, where we are performing validation activities. We deploy AWS through secure environment templates. We create an audit-ready environment. The rules that we've defined within our templates by going through the previous phases sets us up for a successful audit baseline. If we design, scope, and implement properly in the first 3 phases, we can be guaranteed that our security controls are operating 100% at any point in time. We contrast this with traditional audit sampling methods or point-in-time reviews that we would do in a traditional IT environment. We don't know what we don't know. In AWS, that all changes. So digging into the first phase a little deeper, we're going to focus on 4 key types of requirements here. we have the data classification. So it's key to understand what type of data we have, what the impact of that data is, what sensitivity level that data possesses. And then we can talk about the use of that data. So where we can store it, how we retain it, how we process it, how we share it. Then we need to focus on our regulations. So are we bound by governmental regulations, organizational regulations, or do we have our own regulations that we've placed upon ourselves? And then finally, we look at specific security controls. So things we're very comfortable with around access control, audit controls, but things we may not really think of traditionally as security controls, configuration management principles, contingency plans, disaster recovery plans, business continuity plans. Those are actually security controls, and we can take advantage of in this security by design concept. So if you have trouble parsing out what your security requirements really are, here's some helpful questions that will assist you in identifying your requirements. To understand your data classification, you're going to ask, what do I have? What is this data? What is its intended use? Which of the data needs to be protected, and who am I protecting it from? In terms of usage, what can I do with it? Where can I process it? How can I access it? And can I destroy it? On the regulation side, am I bound by legal restrictions? Do I need a third-party auditor? Do I have to go through some sort of certification process? Or do I have to leverage some sort of specific framework, like in the U.S. government, you have FedRAMP, you have the NIST guidelines, the Risk Management Framework. Those will help you answer those questions. And finally, security controls. They answer the questions of who can access the environment, how are those requests audited, how are changes controlled, how do I detect improper access. So taking a look at a very specific example from the payment card industry, the data security standard, here we look at the data classification of that standard is cardholder data. So the payment card industry doesn't really care what you do within your organization with the rest of your data. The thing they care about is cardholder data. And they place constraints around the use of that data. So on the data usage side, they're requiring you to encrypt transmission of that cardholder data if you're sending it across public networks. So there's no real legal regulation around that today. It is being talked about, but they have their own internal regulations within the PCI standard advising the use of strong cryptography and security protocols to safeguard this transmission. So the security controls relevant in AWS are enforcing the use of HTTPS on our elastic load balancers, and moreover, using compliant TLS policies. So we need to make sure that the encryption configuration within our ELB actually matches that which is regulated by the PCI standard. And we also are going to enforce the use of encrypted connections into Amazon S3. All right, moving into phase 2, building a secure environment. This is where we have lots of different options within AWS, and we need to make sure that we are looking at those options through a specific risk management framework. We are going to look at things like specific service selection. Some services just may not work within our organizational construct or within our security control framework. We're going to look at the use of encryption. We're going to look at network segmentation, things we can do with our VPC configuration. We're going to look at our IAM configuration around user permissions, group permissions, role permissions. We're going to look at the use of authorized operating systems. So through the use of AMIs, we can configure and control which operating systems are allowed and which are restricted within our organization. And we're going to look at policies around resource protection. So does a developer need access to a production environment? Probably not. So we're going to look at how we enforce things around that. And then logging. There's a lot of robust logging capabilities in AWS natively. We need to make sure that we're enabling those that are applicable and have a strategy around logging. And then all of these choices that we make, we need to balance with our organization's appetite for risk. So every decision that we make has a trade-off. So either we are increasing our risk or decreasing our risk. Important point to remember, we're never eliminating risk. The only IT system that has no risk is one that's not turned on. I'm sure we've all heard that before. I'm sure somebody's going to argue that. You can even get into a powered up system, but we are going to make the choices best for our organization based on our organization's risk appetite. The reason we're doing that is we're working within the cloud environment. So one of the big promises of the cloud was that we were going to increase our agility. We're going to give more freedom to our organization. We're going to do things much faster. And a lot of times security has gotten in the way of that in the past, and organizations just don't necessarily believe that is true. So what we're going to do is we're going to establish blueprint architectures that allow our individual application owners or our workload owners as much autonomy as possible to make determinations for their applications, while the rest of the controls are automatically applied. So we do that through the use of modularized templates. So we can create nested stacks within CloudFormation. So we can have multiple stacks, one for the application itself, one for maybe the network. So we have different people, different teams that are enforcing different standards in their lanes in the road. So the network security team can focus on building and improving the network template, and the application owner just needs to focus on the compute and data aspects of their application. And then the permissions and logging configuration is also a template. So all of that's applied on top of all of the configuration, and that might be controlled by yet another organization. Maybe our core security team has the only ability to manipulate the permissions and the logging configuration. We're also going to use parameters whenever possible. So we do this for a number of reasons, one of which is to facilitate consistency. So we can deploy these stacks over and over and over by just modifying parameters and get slightly different outputs each time specific to the applications, but not changing a whole lot other than that. We're also going to use stack policies to protect the running resources. So like we talked about, maybe a developer has no need to impact production running resources. We're going to enact policies to prevent that. And then that goes hand in hand with IAM policies to restrict permissions of specific users. So here we're going to look at a specific building a secure environment example. This is going to be out of the NIST Risk Management Framework, specifically the 853 cloud controls. And we're going to be focusing on service selection and network segmentation. And again, we're going to be balancing that risk with our organization's appetite for it. So within the NIST framework, configuration management, control 7A, the principle of least functionality requires us to configure our information system to provide only essential capabilities. So we are going to use a CloudFormation template that deploys an architecture that only provides essential capabilities, and we can programmatically enforce that. So here we have a sample policy or a template which will be deployed, and it will deploy a RDS database, it will deploy an auto-scaling application group, and an ELD, nothing else. So if it's not part of our application, it's not in this template, it doesn't get deployed. You're not going to have any other resources associated with this application running. Another example, so in the system communication control 7B, they talk about boundary protection. You need to implement subnetworks for different purposes, logically isolated from the internet and organizational networks. So again, we're going to define that through the use of a template. This template specifically is going to set up multiple availability zones for HA. It's going to set up public and private subnets, and it's going to set up a management subnet as well. And these templates are actually pulled right out of an AWS quick start known as the Enterprise Accelerator. You can actually check these out. The link here is at the bottom. You can download Enterprise Accelerators for specific security frameworks. All right, moving into phase 3, enforcing the use of templates. So here we have a lot of choices. We've talked about it over and over. AWS keeps giving us new choices every day. And one of the biggest barriers to entry for a new AWS admin is that learning curve. What should I use? What can I use? How do I use all of these things? If we restrict some of those options and we say, we're going to give you access to just what you need to do your job in a very automated and fast fashion, people are going to follow the principle of least resistance, and they are going to use these pre-approved templates because they're quickly going to deploy exactly what you're looking for as an organization, and they're going to ensure that all configurations comply with your organization's security standards. So the key services here are CloudFormation. So again, we're going to templatize every single aspect of our deployment, and we're going to configure all aspects for security from the ground up, and we're going to define stack policies that further control who can do what and how. We're also going to use the Amazon Machine Image, the AMI, to specify which operating systems are allowed within our organization and which versions and what controls are applied within those operating systems. We're also going to apply specific permissions to those AMIs to say who can do what with those AMIs. So you might be able to launch a specific development stack with the development AMI, but only into the development environment. And an additional, one of the newer services, CodeDeploy, we can use this to fully automate custom code deployment. So if we want to layer on our specific business applications on top of the underlying infrastructure, we can use CodeDeploy to fully automate that as well and ensure a consistent application deployment. Moving into phase 4, now we've gone through the entire process. Now we're going to perform the validation activities, ensure that we've followed steps 1 through 3 completely. What that's going to ensure essentially is a completely complete security posture. We are going to guarantee 100% audit-ready environments. So we've deployed everything from a template. We can now baseline everything against that template. It's also going to ensure 100% audit coverage. So we are going to configure logging within the templates themselves. Logging will be turned on and it will be enabled, and we'll also set up rules to prevent and detect attempts to tamper with or disable auditing so that we can ensure that there is 100% audit coverage, which gives us a 100% visibility. So we will have information available to the state of all deployed resources within our environment. And this also gives the ability to provide 100% remediation. So we now know about all resources. We immediately flag non-compliant resources automatically. We generate alerts, and these alerts can trigger automated actions, such as quarantining of any offending resource. The key services here, AWS config. So this is actually going to create a point-in-time snapshot of your architecture, and then it's going to regularly compare your running infrastructure against that baseline. So it's going to automatically detect any resource deviation and then flag those as non-compliant resources. We're also going to use CloudTrail to record all AWS API calls so we can quickly and easily take immediate action for API activity that we see that should not be allowed. And then Amazon CloudWatch is going to enable us to send these notifications of alarms and these conditional breaches. So let's look at a specific example out of HIPAA here for validating our environment. So within HIPAA, the important classification of data here is protected health information, or PHI. So the usage restriction here is that PHI can only be processed in HIPAA-eligible services defined in the BAA, the Business Associates Agreement with Amazon and or your managed services provider. The regulation here is not external, but it's an internal regulation defined by AWS, stating that any service that's processing AWS must be in this list in your BAA. Today there are 9 services available. So the security controls we're going to implement are going to restrict the use of any of the services that aren't authorized through the use of policies, and then we're going to use config to detect any of these unauthorized services that are running in a VPC we know to be processing PHI data. So in closing this part out of our discussion, we are trying to secure and automate all aspects of our deployment in AWS because the human errors are what lead to non-compliance. If we eliminate that factor, we automate everything, it's going to be secure from the start. And these configurations will be automatic and simple to achieve. So they won't be a burden for the rest of your organization. They'll be able to click a button and get what they need, and it will be guaranteed to be compliant at that point in time. We also can finally achieve fine-grained access control. So we've wanted to implement this for years in our organizations. We wanted to say, you know, this person can only do this at this time. In traditional IT environments, that was very difficult. But now we can literally say, this one person can do this one task at this time of day on this specific resource, and that is it. And then finally, an important point, so this is going to generate a lot of logging. So we're going to enable logging all over the place. We're going to be pulling all these configurations out. We're going to be creating alerts and alarms. Managing this in a manual way within your organization is probably not going to be possible based on the volume of data we'll be generating. So we need to automate as much of that as possible and potentially lean on a third-party provider such as Rackspace to provide a managed security service. So with that, I'm going to turn it over to Jarret on my team here to talk about that.
Excellent. Good afternoon, everybody. So as we mentioned, my name is Jarret Raim. So I'm the Director of Strategy and Engineering at Rackspace Managed Security. And our job at Managed Security is to kind of be the top layer of this layer cake, right? You start out with AWS infrastructure, where AWS is responsible for the security, a lot of those underlying components. They then provide you a lot of tools that you can use to then secure your infrastructure, as Brad was kind of going through. Creating all of these templates and focusing on building security in from the beginning allows you to eliminate an entire class of vulnerabilities and misconfigurations and those types of things that you would see in the environment. And finally, the last step is to sit on top of all of that and actively manage and actively hunt inside the environment to both find adversaries that may be compromising your environments and moving forward from there. So from a managed security perspective, we generally talk about multi-cloud worlds, right? It's rare that we find customers that are using a single compute infrastructure. So a lot of customers are pairing their AWS usage with a private cloud or a public cloud or these other various different bits and pieces. And so it's important from a security perspective to start to get visibility across all of these platforms so that you can kind of holistically manage the risk. As Brad was saying, we can never eliminate risk as we're moving through the environments, but we do want to focus on trying to pull all that risk into some place where we can understand it and then implement tools, tactics, and procedures to kind of limit that risk. Right? And as we look at AWS in particular and part of this multi-cloud world, AWS gives you a lot of options that you can consume to secure your environment. And it also kind of drives a little bit of your choices around what technologies you may use and what processes you may use to secure your environments. Right? So as Brad was touched on earlier, we really need to focus from a security operations perspective on being a business enabler. Right? Too often security in the past has been the land of no. Right? If a particular business unit or a particular dev group wants to go out and use a technology that security wasn't able to get their hands around, then we tended to see a lot of, well, you can't do that. Right? And sometimes there can be legitimate reasoning behind that, but a lot of the times it was, hey, look, I don't know how to use this thing, my tools don't work with this, I didn't build my operation to do that. And so modern security operations now, when you live in this multi-cloud world, when you're using these different platforms to kind of meet business objectives, we need to be able to really get behind that. And so that means that as a security operation, we really need to embrace the fact that our techniques that we use to go out and provide security are going to vary. The tools that we use and those types of things will vary between the different missions that we have. And so that really means that we need to focus heavily on the people and process side of security. Right, so when you look back at what is required to really have a modern security operation that's capable of stepping into an environment today and defending against the types of modern attacks we see from what's called the advanced persistent threat or your more kind of modern adversaries, right, it really starts with your people. Right, if you assume that all these different architectures are going to be available to your users inside of your business and they're going to consume them, then the first thing that you need to build is people who are capable of understanding the threats and then being able to actually go out and work inside these different technologies. Right, I think the biggest mistake that we see most customers make is going out and spending an enormous amount of money on very modern and very expensive tooling and then not spending the time, energy, and resources to put a team behind that tooling to make it effective. Right, I always tell customers I'd much rather have a deep expertise team and spend no money on tools than the most expensive tools that are out there and not have the right people to use them. So as you go out and actually gather all of these people, these experts that understand the security space and are able to work in it, then you need to enable them with what we call threat intelligence. Right? And threat intelligence is really just understanding what the bad guys do. Right? It's understanding the people, processes, and tools that are involved in their side of the business. The modern threat these days is generally a business. There are still nation-state actors, of course, that are also in that space as well. And so you need to understand who these folks are, what tools and what techniques they use, right? And then being able to design defenses and design detection mechanisms to be able to find them. Once you've done that, once you've got your people, once you've got your process and they're enabled with the knowledge that they need, then it's time to go look at tooling. right? It's important to, if you have the best people and the best process and the best intelligence, then it makes sense to spend money to enable them with the best tools in the world because they can go out and achieve the mission. I think the other big piece for us is really focusing that security operation around remediation. Right, we assume from a security operations perspective that adversaries will get in your environment. Right, a lot of the techniques that Brad was talking about makes your environment more hardened, more difficult for an attacker to operate in, and that's great. Right, deterrence is a fabulous, fabulous way to really raise the cost on the attacker. Right, and if you look at all the breaches in the last couple of years, we've seen very large companies who have invested significantly in these types of operations and these types of things, and still been breached by the APT or the more modern threat. So deterrence is an important capability and it's an important part of your stance. But the second piece is you got to build an operation where you assume that the adversary is going to get into the environment, right? And if you do that, then you're going to focus most of your time on detection, like find the adversary as soon as they get in your environment, and then get rid of that adversary before they're able to do any damage, right? So if we look at that rapid detection and response piece are kind of two legs, and then finally the deep expertise component that we've been discussing, right? So if you really focus on detecting the adversary as soon as they get in and removing them very, very quickly, right, then you limit the damage they can do to the business, right? The average time a company is breached these days is about 150 to 200 days between the day that that the company is breached itself and the day they find out about it, right? That's an enormous amount of time that the attacker has to pivot through the environment, find sensitive data, exfiltrate it, achieve persistence mechanisms. So it's very common that if you go into an organization that has an ongoing breach or had a breach and you start trying to clean it up, the adversary will just go dark on you. So they stop moving around, they stop doing anything, and they wait 3 or 4 months until you've stopped paying attention, and then they come back in through these persistence mechanisms. So if you really focus on kind of detecting and responding very, very quickly and removing them from the environment, then you could have a lot more success at keeping them from actually, attacking the business or providing business damage, and it's significantly cheaper in being able to deliver, right? Then once you've built this operation, you really need to understand your data and understand its business value, right? So Brad talked a lot about understanding what data you have from a data classification perspective and how that could impact your compliance obligations and those types of things. It also impacts your security operation. Right, so the way that the Rackspace Managed Security team responds to an incident varies based not only on the type of incident that we're looking at, the type of attack that we're looking at, but also the value of that particular asset to the business. Right, so we have what we call pre-approved actions, and these are during your onboarding process. We go through with customers and we say, hey, look, if we see this particular type of activity in your environment, here's how we're going to go ahead and operate. Right, here's the run book that we're going to execute. Are you okay with us doing that without talking to you? Right, and that allows us to really use our rapid detection capabilities, respond very quickly, but how we choose those pre-approved actions is partially based on business value. Right, so if we look at a particular asset, a database that is very sensitive to the company, we may want to turn that database off rather than lose the information in it. Right, so you'd rather take downtime. That downtime is less damaging to the business than possibly losing that data would be. Right, the second piece that you need to look at is really abandoning this traditional reactive posture. Historically, SOCs have, or security operations centers, have put a bunch of tools into the environment, waited for those tools to alert, and then responded to those alerts. And that's still required. You still got to do that type of stuff. But the fact is that most modern tooling won't detect the APT. If you want to find these more modern attackers, you have to go in and look for them. It's a process that we at Rackspace call cyber hunting. It was originally created as part of the Air Force and the NSA, and a lot of the folks that were involved in creating that are now Rackspace employees, and they've helped us build this capability internally. So cyber hunting is this proactive mission. Right, it's our security analysts in our security operations center here step into customer environments, sans an alert. Right, they're not responding to something a tool has told them. They're generally going into that environment and looking for evidence of an attacker. Right, so the analogy that we like to use with a lot of customers is if you go to the scene of a bank robbery and you're looking around outside and behind one of the hedges you find a little pile of cigarette butts, you may think, oh, hey, well, maybe the bad guy kind of stood here and cased the joint before they actually performed the robbery. Well, then if you go across town to another bank that hasn't been robbed yet and you go and look behind their hedge and you find some cigarette butts, well, maybe that tells you that this might be a place that the attackers are interested in. And that's the type of stuff that cyber hunting is looking for. It's not looking for things that in and of themselves are indicative of an attack, although if they find that, great. Right? What they're looking for is evidence of the fact that an adversary might be operating in that environment. And that's the way that you can find a lot of the APT components. Right, and finally, we talked a little bit about this, is enable immediate action to protect data and minimize business impact. What you can't be doing is calling around trying to find people at 2 o'clock in the morning to find out whether or not you can turn off a particular service, whether you can change the password of a particular user account, those types of things. So you need to not only be able to perform those actions off the top of it, but during an incident, needs to not be the first time that you perform those actions, right? So drilling is a very important component of this. If you don't know if changing the password of a particular user account is going to break your application, then you're going to be reticent to do that in the middle of an incident. And the last thing you want to be trying to figure out, you know, when everybody's stressed out and everybody's been up for hours and everybody's scared, is trying to make these decisions or find out this type of information. Right, so we drew this diagram before. We'll pull it up again. So when you start thinking about your AWS security posture, you start with that secure foundation that AWS provides, right? It provides the data center security, the compute, and the networks, and the storage security pieces that they're responsible for and deliver. And they're able to give you all of those assurances around the different regimes or various other pieces that they've gone out and gotten, so that you can not only, you know, believe that they're doing what it is that they say they're doing, but you can prove to your customers and your business that you're doing that. Then you layer the fanatical support for AWS on top of that. This is a Rackspace offer, and Rackspace is now helping you consume all of the tools that AWS has built in the most effective way. And Brad went through a lot of examples about how you can use this tooling that AWS has provided to, you know, secure your infrastructure by design from the beginning, so that we can't screw up and provide these kind of, or make these basic mistakes that give attackers the cracks in your armor that they need to get in. And then finally, you sit on top of that with a fully managed kind of focused security operation that's looking at your environment, that's monitoring all of the tooling in your environment, and that's making sure that if an adversary does get in the environment, that we're able to prevent that adversary from inflicting business damage on the organization. Right, and that operation is really based, we like to say it's based on people, processes, and tools is 10% of the problem. Right, so having that 24/7 coverage, having the process and the understanding and the training to be able to execute on that very quickly, right, and then of course enabling those with the best of breed security technologies so that you can find the adversary and respond to them very quickly is an important component. So we're kind of towards the end here of our prepared content. We wanted to leave about 15 minutes here for questions, so we've got plenty of time. I see there are a couple up here as well, so we'll get started. So as we've kind of talked before, you know, understand your data protection requirements. This is a key component to being able to understand how you need to go and actually design, right? So AWS gives you an enormous amount of tooling. The important piece is understanding what tools you need to go use to achieve the objective that you have, and of course to do that, you need to know what your objectives are. Right? Your needs do dictate your security strategy from your business perspective, right? But AWS has given you a lot of the tools that you need to be able to get there. Right? So with that, we will move on to the question and answer section. So if anyone has questions, please go ahead and enter them into the Q&A piece, and we will answer them for you.
There was a question posed. Oh, sorry.
Yeah, go ahead.
There was a
go ahead, Brad.
question posed earlier about the scope of a template. That's a great question, and that's going to vary by organization. Specifically, when Rackspace is helping a customer manage their AWS environment, the scope of our templates are going to go basically up to the operating system, maybe the middleware level, and then when the application specific configuration takes over, that's going to be out of scope of that template. But then that might be another template. So you might have a template that you control and your managed services provider controls the other template. So it really depends. There's a question about a high-trust certificate. I don't know if that's for AWS or for Rackspace specifically, but we'd have to look and see if we're able to provide that on AWS. The managed AWS services we're providing, the managed security services, they're both fairly new. So we have specific certifications already for the rest of our business. Some of those we are transitioning to our AWS services and our security services on top of AWS. The most recent of those are actually our ability to provide PCI compliant environments as well as HIPAA compliant environments. So we have gone through an audit for PCI, and we are able to provide that report of compliance if necessary for your organization.
That's a good question. I think generally we get a lot of questions around compliance from various different customers. There are a lot of compliance regimes that may apply to various different businesses and various different verticals. Right, and I think there's certainly certifications that are required for some of these. You saw that in the slide that Sai showed of all the different certifications that AWS has, right? And then as you start getting into using the tools correctly, a lot of times for most people that are in the compliance area already kind of know that a lot of the technical controls that you're going to put in place, the actual things that you're going to do in your environments are very similar or exactly the same across a lot of these different compliance regimes. Right, so a particular action that you may take to meet section 3.2 for PCI may meet something in ISO, may meet something in 800 WAC 53, or something in the CSA, or any of these types of things. So there's a couple of good resources out there for mapping those things together. Archer is a typical one that most people use, although it can be a little bit expensive. Another one is the Unified Compliance Framework, or UCF. And what these allow you to do is kind of plug in what requirements you as a business have, and it'll mix and match all of those different compliance regimes down to give you a list of things that you need to implement. Right, and that really leads to Brad's original point of understand what requirements that you're trying to achieve. Right, so if you've got 6 or 7 different regimes that you need to deal with, rather than trying to manually go through them all, it can be very useful to go down in and actually say, okay, well, let's combine all of these 7 or 10 things to a set of controls, and then, you know, Rackspace or your internal teams can go and help you implement the technical controls that you need to meet those policy statements. Let's see, so there's a question here about IDS IPS that feeds logs into incident monitoring management programs. So Rackspace Managed Security does include IDS, so we actually kind of talk about capabilities from our perspective because the tools can vary depending on the different infrastructures that customers are using. So we have what we call the triple stack, which is a host-based protection platform that gives us kind of deep visibility into what's going on the host itself. So it's an agent that sits in your virtual machine. Then there's also an IDS component. As you can imagine, for most people that are used to more traditional IDS, it's a little bit different in AWS, right? So there's not a span port on the switch that I can go and tap to get the traffic. So the way that we generally do this is there's an agent that gets deployed in your virtual machine. That agent collects all of the logs from your environment. That agent also collects network traffic from that particular host and forwards it to a virtual appliance that we place inside your environment at AWS. That virtual appliance then does the normal IPS or the normal IDS functionality talking to the backend, right? And then of course all that data from the IDS and those components flow up and down into our security analytics solution, which is your traditional SIEM plus some other big data technologies that are out there. And that's really what our Security Operations Center sits on top of, right? It's got all these different telemetry feeds that are coming in and then are being monitored and responded to by the SOC. And then the SOC is, of course, using all of that telemetry information to perform that cyber hunting mission that we talked about. So it's a good question there. I think a lot of folks struggle with how do you do the traditional security things in AWS sometimes. There are vendors that have really moved to using AWS effectively. There are a lot of vendors who haven't. So definitely an important component of building out the operation is understanding the types of differences that you may have between your tooling.
All right, I'm going to roll a couple of these questions up into one. There's a question about, other than helping with security, what other things does Rackspace do, as well as a question about AWS offering so many tools and services. How do we get help with those tools and services? So, I mean, that is exactly what our Fanatical support for AWS provides. We provide that insight into AWS services. We help you architect your applications on top of AWS services. We implement those architectures, and then we help with the ongoing operations and sustainment of your environments. So we're helping with all aspects of that. And then in conjunction with our managed security services, we can take that proactive security posture on top of all of that. There was another question about security for S3 images. I think you're referring to the Amazon machine images, the AMIs. Are they safe from ransomware? So that's a great question. Some AMIs, specifically the ones provided by AWS, I know undergo some rigor of security analysis. But I mean, ultimately, your own requirements are going to dictate what you need to do there. So you may still want to perform some sort of review on the images you're getting from anywhere. And also, that vanilla OS image is likely not to meet your security requirements. So you're going to want to provide additional security controls on top of that operating system anyway. So as you go through that process, you're likely to detect things like ransomware or other things that may have creeped into the operating system images. There was a question why Postgres is not listed as an available HIPAA service. That's a question for AWS. So AWS keeps that list of services they are willing to support in the BAA. So I don't know if Sai can provide any comment on that.
Yeah, sure, Brian. For now, we have Oracle and SQL Server as the two obvious database engines that are under the HIPAA eligible services. But we have been getting a lot of feedback from customers about Postgres. So we are working on that. So please keep an eye out. So we're trying our best to get this out as soon as we can.
And just to kind of tag on to the kind of ransomware question, I think, from a malware perspective, ransomware typically propagates through the environments using traditional file sharing techniques. So a lot of times you see a ransomware piece that will hit an endpoint, and then it will use the endpoint's access to other things like file shares and those types of things to propagate inside the environment. So when you look at, hey, if I have a particular host inside of AWS, like one of my hosts got ransomware for whatever reason, could that ransomware then pivot to other virtual machines inside of my environment? Possibly, depending on how they're set up. I haven't seen anything, or I haven't heard of any malware that is explicitly trying to jump into the AWS infrastructure, right? So there's always a separate question of, well, what happens if an adversary gets my AWS credentials, and then they could use those to infect AMIs and various other things that may be part of our solution. But I haven't seen any ransomware that's done that yet. Doesn't mean that it won't happen or that it's not even happening now, but not something that we've seen today. Most ransomware is still relatively unsophisticated in the grand scheme of things, although that's rapidly changing now.
Yeah, and picking up on that point, the question of AWS account compromise comes up quite often, and obviously that is a very big concern. If your account is compromised, everything in it could essentially become compromised at that point. So we take a lot of steps when we are working in a customer environment. We advocate the use of only IAM roles using temporary credentials, so we don't use any static permanent credentials. We do account level separation between environments. So we actually advocate that a customer set up a development environment in a separate AWS account, a test environment in a separate AWS account, and really limit the blast radius of any of those account compromises. And then occasionally, if it's a very sensitive workload, we may advocate that they actually have another account where they're performing regular backups of resources, which has a completely separate set of credentials to protect you in that case.
Yeah, it's a great point from Brad. I think, identity and access management is hard no matter where you do it. AWS gives you an enormous amount of tooling, very fine-grained tooling in the IAM platform to be able to be very specific about it. So use that stuff, right? The last thing you want to do is have admin credentials floating around that developers are using because they have access to one particular part of AWS. You can really kind of scope those credentials down very tightly. That does mean it's more work to control them, but it does give you a lot of backup benefit that if those controls are leaked, then there's less chance that an attacker can use them. Which kind of flows into another question here that someone asked, which is, hey, we've talked a lot about EC2, but what about all the other stuff in Amazon, things like S3 and Dynamo and Lambda? Really great questions, right? I think two answers here for me. The first is that every organization needs to have a conversation internally about how much visibility they're willing to give up for the operational benefits that they get of platforms. And this is really that conversation between infrastructure as a service, platform as a service, and software as a service, right? The farther up you move in that stack, the less visibility you as an organization have into what's going on. So the more you're trusting your provider to provide it for you. So if you go with a Lambda or a DynamoDB, you're explicitly trusting AWS to do more of the security around that infrastructure, right? And they're going to provide you a lot of information about what they're doing. And so then you'll need to decide as an organization, is this the right level of risk for me? Are we okay with the assertions that AWS is making and the evidence that they're providing us? Or do we want to have our own visibility that we can get to it? Right? So that's always a good conversation. It's not an easy one to have, right? So we tend to spend a lot of time having that conversation with customers when they start talking about using these types of platform pieces. So anyway, like I said, easy to say, difficult to do, but important to really think about whether or not you as an organization need to have your hands in something, or whether you're okay letting another platform doing it. And you've also got to factor in these business components that we talked about earlier, right? It's not good enough to just look at this from the security point of view. We also have to look at it as what are the benefits of using DynamoDB to the rest of the business, right? Or using Lambda to the rest of the business. If it's going to mean that I need 8 fewer operations people because I'm using these platforms, and that's going to save me X amount of dollars and get me to market Y faster, right? Then that needs to be factored into the types of things that security needs to think about, right? So a very common conversation we have with a lot of customers. And we're absolutely happy to have it deeper with customers as they want to. Just feel free to reach out. But very, very good question there.
I think we have time for one more question here. There's a question around templates, and assuming we mean codable, does a security professional need coding abilities, or can they do it via the GUI? That's a really good question. If you're going to try and do it all yourself and use the native services to do a lot of this, there will be some level of coding. So most of the configurations we talked about are based on CloudFormation. So you are going to have to create CloudFormation templates. There's a lot of references already out there, however. I mentioned the AWS Enterprise Accelerators, so that's a great starting point. Go in and check out those quick starts and the Enterprise Accelerators that actually give you that baseline risk management framework already applied in CloudFormation, so you have a starting point. But that's exactly why we came up with our managed AWS service, because we realize that not every customer is going to have that expertise in-house, so we'd like to be able to help you provide those capabilities whenever possible.
Yeah, thanks, Brad. One thing I want to add is for a lot of these questions, Rackspace works very closely with our enterprise support, so they have access to our technical account managers, cloud support engineers, and they work with us very closely in helping customers in some of those scenarios. I think we're almost at the end of our hour here. I want to thank Brad and Jarret from Rackspace for presenting with us today. Also, thank you everyone for taking time to join the webinar today on best practices for security compliance on AWS, and enjoy the rest of your day.